Hi, I want to show you an example of how to use Unicode characters inside your program. Basically, we are not going to use Unicode in this course, but I just want to make sure that you know that it is possible, in case you ever want to do it. Let's begin by opening this file, UTF8 Example.asm. There are a few things which are new inside this source file. Maybe the first thing which can see is this include statement. Include encoding UTF8.inc. If you want to use UTF8 inside FASM, you will have to include this file. The next thing which is pretty new inside this file is this line. First we have the operator du, which we haven't seen before. Here du has the job of Unicode. U here stands for Unicode. Next we also see two Unicode characters, ni hao, ended by a zero terminator. Basically the program doesn't do anything. I just wanted to emphasize how to put Unicode strings inside your data, for example. I want to talk a bit about du. You might be wondering what is du and how come we didn't see it before. Usually, du is exactly the same as dw, which means that du will usually declare words, pairs of bytes. However, if you add this include, du has a new meaning. Whenever you add this include, du will mean Unicode characters. FASM will be smart enough to translate those characters into the correct encoding in UTF-8. But to allow FASM to do it, you have to specify du. And you also have to add this include. Another thing to know about Unicode is that your editor should support Unicode, or else you could not add those characters inside the file. I'm currently using Vim, and as you can see, Vim does support it. Probably, if you use some known editor, it will support Unicode too. Let me show you an example. If we open this file with Notepad, we can see here too that the editor supports Unicode. I think that it is pretty interesting to see what is the output file like. How will it contain those characters? So let's assemble the program and then open it with the hex editor. The assembly went okay. Now let's open this file with hex editor. I changed the alignment to 8 bytes just to make it easier for me to look at the table of sections. Currently I want to find the data section. As we already know, we can just use those two D words to find this section. We already know that this D word is the size of the data section inside the executable file. And this D word is the offset inside the executable file of the data section. If, for example, we will go to offset 200, we are going to find the beginning of the data section, which is here. Basically, if you ever don't remember what is the meaning of every D word here, you can just guess. It will work just fine. If we begin from here and we go down, at some point we see those strange bytes. Because we know that the data section is the first section to appear, we can guess that this is the data section. In addition, it also begins at a very round address, 200 hex. By now we know that this is where the data section begins. Let's try to find out what are those numbers, and if FASM did a good job converting the Unicode characters into the correct encoding. We have here those two pairs, and probably the null terminator is somewhere here. I leave it to you to find out what is the size of the null terminator. Is it 1 byte or 2 bytes? Find a way to do it. Let's open the character map to find out what are those numbers. This is the character map. Now we have to write those numbers to find out if we got the characters correctly. If we just write this number 60 for F, we will get an incorrect character. You might be surprised, but at this point you should probably remember that we are dealing with the x86 architecture. Therefore we have to take it in the reversed order because of the little endian convention. Therefore we have to write 4F and only then 60. So let's change it. 4F 60. And this time we got it right. This is the character ni, which corresponds to the first character we have written inside the source file at my star. Let's check the second one, which is 7D 59. Let's write it down. 597D. And indeed, the second character is how, which is correct. This is what I wanted to show you about Unicode. It was really basic, but I just wanted to make sure that you know that if you ever want to write anything Unicode inside FASM, it is really possible. See you on the next lesson.